Today we're going to cover section 6.5, rotation of axes, the general form of a conic. So this first theorem that we're going to talk about, what it first does is it shows us how equations are broken down. So this here is how they're going to be broken down. So it's going to be the coefficient A will go with x squared, the coefficient C with y squared, the D with x, the E with y, and then for the constant it'll be f. Now, the thing that's important is in this equation is that A and C are not both equal to 0, and if that's the case, then we can define, using this equation, the product of A times C to see if it's a parabola. If it's a parabola, either A or C is going to be equal to 0. If it's an ellipse or potentially a circle, A times C is going to be greater than 0. And then if it's a hyperbola, A times C is going to be some negative number. So let's go ahead and do some examples so you can see. And again, the only thing that we really care about in determining what kind of a graph it's going to be is by looking at A and C. So in this first one, A is going to be 3, C is going to be 6, and so we see that A times C is 3 times 6, which is 18, and that is A times C is greater than 0. So we have we have an ellipse here, and that's all we have to do. For B, we see A is 2 and C is a negative 3. So then A times C is going to be equal to a negative 6. That tells me that A times C is less than 0. Since it's less than 0, this is going to be a hyperbola. And then this last one, we can already see by what it is. A is 0, C is 1, and so A times C is going to be equal to 0, right? Because 0 times 1 is 0, and so this is clearly going to be a parabola. So this is how we classify these different types of conics without completing the square. Okay, now this next thing that we're going to do is going to be the thing that's going to be tricky. We're going to do a couple of examples that are going to be really, really long. And so what's happening here is when we have equations that have a product of x and y together, there's typically a rotation that happens that can make it so that the axes, instead of being the xy axis, we can rotate by some certain angle and then build our axes from there. So let's do this simple example first to see if you guys can see it. One of the things that's important is they're telling us that the angle is 45 degrees. We see that it's that product xy. That right there, when we see that, is telling us that there's going to be some sort of shift. And so we're going to use this equation here to go ahead and break this down. And so x is going to be equal to x prime cosine of 45 degrees minus y prime sine of 45 degrees. And that's going to be x is equal to the square root of 2 over 2 x prime minus square root of 2 over 2 y prime. This is my x value, the substitution in terms of primes. Y is going to be written as x prime sine of 45 degrees plus y prime cosine of 45 degrees. And so that's going to be y is equal to radical 2 over 2x prime plus radical 2 over 2 y prime. And this is the breakdown for y. Now, in order to come up with our equation, we're going to substitute into the original. So sub into xy equals 1. And so we're going to get square root of 2 over 2 x prime minus radical 2 over 2 y prime. That is my x value times my y value, which is radical 2 over 2 x prime plus radical 2 over 2 y prime, and that's supposed to be equal to 1. Now, we can factor out radical 2 over 2 from both of them, so we'll get radical 2 over 2 times radical 2 over 2, and that's going to leave us with x prime minus y prime, and x prime plus y prime is equal to 1, and that's going to simplify to be 1/2, and the inside piece is going to be x prime squared minus y prime squared is equal to 1. And then we can write this in terms of x prime squared over 2 minus y prime squared over 2 is equal to 1. And this is our equation. Now, this equation that we have should be familiar to you, very similar to what we did in previous sections. This is actually a hyperbola, but what's happened to the hyperbola here is the axis of rotation has been shifted 45 degrees, and so this shift of 45 degrees is going to make it to where this now is going to be our x prime axis, and then going this way, this is going to be our y prime axis. And so what we end up seeing is we can actually graph this thing. That angle rotation is 45 degrees right there. So basically, what was the x-axis has been shifted over 45 degrees. What was the y-axis has been shifted 45 degrees. Now, to graph this thing, we've already done this. So remember, I would draw my box, and so we can see that since this is a hyperbola, my x squared term is positive. So in terms of x, it's going to be opening along the x-axis, so that's, or the x prime axis in this case. So I know that I'm going to get a value of radical 2, and radical 2 is just over 1. And we're going to get it on the positive and the negative side. And then along this y prime value, we're also going to get a radical 2 over 2 value right there. And actually, I should use a different color for that so you guys can see, so we can remember how we were doing it before. And then what we do is we're going to create those that box, right? And this box is going to create our asymptotes for us. And in this case, it's interesting. The asymptotes actually are the x-axis and the y-axis. And so in fact, let me dot it so you guys can see. These are the axes, the y minus b over a and the y equal to negative b over a. And when we draw this thing, then our parabola is going to actually look like this. Or, I'm sorry, our hyperbola is going to look like this. and it's just really building on what we've done in the past, but we have to realize that we rotated again. This angle was rotated by 45 degrees, and that was given from right here, rotating the axes by that 45 degrees. Interesting, right? There's a theorem that comes with that so that we can find the angle, and this is the information that we're going to need. Again, this has that XY product, and so that tells us that there is potential to graph this with a rotation. And so to do this rotation, we need to label some things, and so this is going to be quite a bit of work, but bear with me. So let's label some points. So A is going to be 1, B will be radical 3, C is going to be 2, our F is going to be a negative 10. And so what we're going to end up doing is seeing if we can solve this thing. And so cotangent of 2 theta is going to be equal to 1 minus 2 over radical 3. So cotangent theta, 2 theta, is going to be equal to a negative 1 over radical 3. And that is going to put us within the first and second quadrants, right? Because of what cotangent is. And I'm going to clean this up just a little bit because I just like it prettier. So it's going to be negative radical 3 over 3. And so where do we find this? If we look at the unit circle, we see that 2 theta is going to be equal to 120 degrees. And so that tells us that theta is 60 degrees. And so what this is telling us is that we're going to have a rotation of the axis by 60 degrees. And so we're going to have to do that, but no problem. We'll get to that in just a second. Now, we have to do the substitution. And so we need to find out what x and what y are in terms of primes. And so I'll do this one over here. So x is equal to x prime cosine of 60 degrees minus y prime of sine of 60 degrees. And so that's going to give me x is equal to 1/2 x prime minus radical 3 over 2 y prime. And I can clean that up, and I think I'm going to this time, as x prime minus radical 3 y prime. We have to remember that, so we should kind of highlight that and remember that. And then y is going to be x prime sine of 60 degrees plus y prime cosine of 60 degrees. And then that's going to be y is equal to radical 3 over 2 x prime plus 1/2 y prime. And again, we want to remember that, so just kind of highlight that. And then we're going to substitute that into the original equation. And so I'll rewrite the original equation just so we have it, because this is going to be kind of ugly in terms of just the length of amount of work that we're going to do, and then to be able to graph it. So I'm going to go 1/2 x prime plus radical 3 y prime, and that whole thing is going to be squared, because x squared is equal to that plus the root of 3, and then I'm going to have this product of 1/2 x prime plus radical 3 y prime times 1/2 Oh, I didn't clean this one up, and I will right now. It's going to be radical 3x prime plus y prime, just so it's cleaner. And so this is going to be radical 3x prime plus y prime. And that's all being multiplied by that radical 3. And then plus 2 times 1/2 radical 3x prime plus y prime. That quantity squared minus 10 is equal to 0. So you can see there's quite some work to this, and then expanding this is going to take some effort too. And so yeah, it's going to take a little bit, but we can do it. So 1/4 x prime plus radical 3y prime squared plus radical 3 of 1/2 x prime plus cube root of 3y prime. In fact, I'll just leave it like that for now. 1/4 radical 3x prime plus y prime plus 2 times 1/4 radical 3x prime plus y prime, that quantity squared. And then what I'm going to do is I'm going to move the 10 over to the other side. Just to try and clean this up. And now one thing I want to show you is there's a 4th here, there's a 4th here, and then these two multiplied will give me a 4th also. So I'm just going to multiply by 4 to get rid of those. And so I'm going to get, and then I'll expand these guys too. So I'm going to get x prime squared plus 2 radical 3 x prime y prime plus 3 y prime squared plus radical 3 times radical 3 x prime squared minus 2x prime y prime minus radical 3 y prime squared. All of that right there is being multiplied by that radical 3. Plus, we have that 2. And then this is going to be expanded to be 3x prime squared plus 2 square root of 3 x prime y prime plus y prime squared, that whole thing, and then that's going to be equal to 40. So that 1/4 I multiplied by 4 to get rid of it, to clean up the math, and you can see just how tedious this can be. Now in cleaning this up, I'll leave that to you to clean. It ends up becoming 10x prime squared plus 2y prime squared is equal to 40. And so when I go to clean this up, I'm gonna make it so that my fractions are, I need this constant to be a 1. So what's gonna happen is I'm gonna get 10x prime squared divided by 40 plus 2y prime squared divided by 40 is equal to 1. And when that gets cleaned up, I'm going to get x prime squared over 4 plus y prime squared over 20 is equal to 1. And so from this case here, since there's a plus, I just want to make sure, see it be consistent. This right here then is going to be the equation that we're going to have. And that equation should look similar to you now. It's in primes. And so what happened here is we have an ellipse, right? We have an ellipse. And so the center of it is going to be at the origin after the rotation. And so remember, the rotation is a rotation by 60 degrees. And so to have a rotation by 60 degrees, that's going to occur, let's see, I'll do it in red so you can see it. It's not going to be perfect, but that's okay. This is going to be my x prime, and then trying to be perpendicular to that. That's kind of off, sorry. That's not too bad. There's my y prime, and so we can see that along the x, that is going to be a distance of 2 away from the origin. And so let's say this is 1, this is 2. There's a point, and then this is 1, this is 2, and so there's a point. And then that 20, the square root of 20, is our other value, and so that's going to be the same as 2 square root of 5, or almost 4.5. So 1, 2, 3, 4, 5, somewhere about there. It's 4.47. So 1, 2, 3, 4, 5, and so the ellipse that we're going to get is this one. And so we can see that this ends up being the major axis because the y is bigger, and that's how we graph it. But the work behind it, you can see, is somewhat tedious, with the crux being this substitution here that we do, taking our equation and subbing in for the 2 green values for x and y, and then doing a bunch of algebra. So this isn't pretty, but once you get to the point that you've converted, it is doable. It's just going to be time consuming. The next example I'm going to show you is like a marathon, so bear with me as we go through it. Here we go. Alright, so in this example here, again, we're going to have to label for our points. And so my A is going to be 4. My B is going to be a -4. My C will be a 1. And we need to remember that cotangent of 2 theta is equal to A minus C over B. And so that's going to give us a 3 over -4, or we can write it as -3 over 4. Some of the information that we were given earlier is in order to be able to turn it into the primes, we need to convert to sine cosine. And so to convert to sine cosine, we need to know where we're at. And so cotangent of 2 theta being negative is going to occur either in the second or third quadrant. So because this is negative, we're going to fall in the second or third quadrant in terms of our cotangent value. And then we need to remember some stuff that we have from back in the past. So cotangent to theta is equal to x over y, because tangent is y over x. And so with that, we can go x squared plus y squared is equal to our r squared, because we need to be able to see in terms of converting to find out what our other value is going to be. And so our x is -3, so -3 squared plus 4 squared is equal to our r squared, and that leads to r equaling 5. That's going to be important because we can then go and find our cosine value, because we're going to need one of our trig identities to be able to convert to sine and cosine, and that is sine of theta is equal to the square root of 1 minus cosine 2 theta over 2, and cosine theta is equal to 1 plus cosine 2 theta over 2. And so using the information that we have, we had cotangent 2 theta, so then cosine 2 theta should be a -3 over 5, because we found our r, remembering that cosine is x over r. And so now we can substitute to go ahead and find our sine and cosine. And so we can find those values to do this problem. So then sine theta is going to be equal to 1 minus a -3 over 5 all over 2 rooted, which is going to give me sine theta is equal to 1 plus 3 over 5 over 2, which cleans up to be 4 over 5, or we can think of it as 2 radical 5. Quite some work, right? This ends up working out to be a theta of 63.4 degrees. So we know what the axis of rotation is. Now we need to go find our cosine theta, and so cosine theta is going to be 1 plus a -3 over 5 over 2. And that's going to be 2 over 5 over 2, which cleans up to be 2 over 10, or cosine theta is 1 radical 5. And then we can clean those up too. That's equivalent to 2 radical 5 over 5, and this cleans up to be radical 5 over 5. So those are going to be two values that we're going to need. And then we now know the angle of rotation. And so we have to remember x is equal to x prime it's equal to x prime cosine theta. So cosine theta is radical 5 over 5 minus sine theta y prime. Let's not forget the primes. That's something that's important. We can clean that up a little bit and pull that out 1/5. So we're going to get radical 5x prime minus 2 radical 5 y prime. Oh, and I didn't even see it. I can actually pull out the radical 5. So I'm going to get radical 5 out here, and I'll just clean that up so it looks nicer. So I'm going to get x prime minus 2y prime. That's my x. And then my y is going to be y prime, sine theta, so that's going to be 2 radical 5 over 5 x prime plus cosine of that 63 degrees y prime, and that can be cleaned up also. I can pull out radical 5 over 5, and so I'm going to get 2x prime plus y prime, and there are my x value substitutions in terms of the new rotation that we've done. And now we have to use that to substitute into the original equation. So sub into or for the x and y, and this is the equation just so we have it. And so subbing those values in, it's going to be long. It's going to be 4 times root of 5 over 5 x prime minus 2y prime squared, right, because that's our new x, minus 4 times root of 5 over 5 x prime minus 2y prime times the y, so that term is the minus 4xy, and then plus the y squared, which is going to be square root of 5 over 5 times 2x prime plus y prime, that whole quantity squared, plus 5 radical 5, and then x, right? Yes, x. So that's going to be times radical 5 over 5 x prime minus 2y prime. And then let's move the constant over, so it's going to become a negative 5. And we can see that each and every one of them has 5 in it. So let's go ahead and see if we can cancel some things out by multiplying everything by 5, and I'll also expand it. And so by multiplying by 5, I'm going to get rid of all of those denominators, and so I'm going to get 4 times x prime minus 4x prime y prime plus 4y prime squared, well, that should be squared, minus 4 and 2x prime squared minus 3x prime y prime minus 2y prime squared. That's that second term, plus 4x prime squared plus 4x prime y prime plus y prime squared plus 25x prime minus 2y prime is equal to a negative 25. You can double check my math, but I believe I've done it correctly. But as always, you should not trust me. Check for yourself. This will then simplify to become 25 y prime squared minus 50 y prime plus 25x prime is equal to a negative 25. And then we can divide everything by 25. And so I'm going to get y prime squared minus 2y prime plus x prime is equal to a negative 1. And then, of course, we can see that we can complete the square, and so I'm going to get y prime squared minus 2y prime plus 1 plus x prime, which if I add to one side, I have to add to the other. and this ends up being y prime minus 1 squared plus x prime is equal to 0, or y prime minus 1 squared is equal to a negative x prime. We can see that this thing ends up being a parabola, and now we got to graph this thing. And so the rotation that we got was 63.4. Obviously I'm not going to be perfect in my sketch, but it's a 63.4 degree rotation. So I'm going to say, let's just say it's something like this. Oh, that's terrible. It should be perpendicular to that line. I know that's not quite perpendicular, but good enough. Okay, now from here, I see that the vertex for this thing is going to occur at, the vertex occurs at 0, 0, positive 1, right? 0, positive 1. And so here's the thing that's interesting about this. Actually, this is bugging me. It's not. Whatever. This is y prime. This is x prime. This is the positive way. So this is positive. And this is the positives for the y primes. And so 0, 1 is going to occur right here. And then we can see that when y is 0, x is going to be negative. So there's our point right there. And just like parabolas, then this is the axis of symmetry. And so there should be a point over here, and this parabola is going to look like this, and that's how we graph it. I know it's quite some work, but with a little bit of practice, you guys should be able to do this. Now, let me do an easy one for you, and it's based off of this theorem right here. And so this equation looks very, very ugly, but the only thing that we care about are A, B, and C. And A is 8 in this case, our B is a negative 12, and our C is 17. And so what we're looking at is something that looks like what we did with quadratics, the discriminant. And so it's B squared minus 4, I should use capital, be consistent, 4AC. And so B squared is a negative 12 squared minus 4 times 8 times 17, and that's going to give me 144 minus 4 times 8 times 17 is 544, and so we see that we end up with a value of a negative 400. Let me just confirm that. I don't trust myself. Yeah, it's a negative 400. And so that puts me in the case where B squared minus 4AC is less than 0. And so that tells me that this must be an ellipse. And that's all we're looking for in this case. It's just saying identify what it is. I know this is a bit of a challenge, but with some practice you should be able to do this. I hope you found this video beneficial, and as always, all the best.